In this section, we're going to talk about containers. Now, containers have been gaining a lot of recognition in the industry today, and a lot of people are starting to use containers. So I want to focus on exactly what containers do for you and don't do for you, and ways of thinking about using them. And I want to be crystal clear on the terminology here. There are container images, and then there are containers, which is a running instance of an image. So let's walk through this. A container image, it is immutable. That means once you create the image, it is set in stone and it should never change. Okay? And it defines a version of a single service along with all its dependencies, which would include things like runtimes and libraries and so on. And you end up using that same container image everywhere, in development and testing and staging and in production. So once you've created this image, you would then test that image. And then that same image would go to staging and production. And because it's immutable and because it is self-contained, right, the testing should go easy, it's self-contained, and because it's immutable, it should be the exact same thing that you're running in all these different environments. Now that's what a container image is, right? It's basically all the code and runtime engines and all your dependencies that you need for your service to execute. Now a container itself is a running instance of a container image, and the container is an isolated environment, meaning that what happens within a container shouldn't have any effect on any other containers or virtual machines or physical machines that you have running in the data center. And multiple containers or services, they can run side by side, as I was just saying, within a single PC or virtual machine. So let me show you some graphic images here to help make this clearer. Let's say that I want to create a container image. I should really put the word image here. This is a container image that has service A in it, and it's for version 1 of service A. So that requires the service A code. Let's say it's version 1 of service A. That might have a dependency on some library. We'll just call it library L for library, and maybe it's version 2 of that library. And maybe this requires some runtime, like a Java VM or a .NET Common Language runtime, and that's version 5 of that particular runtime engine. So we go and we build all of this into a container image, and then we can go and create an instance of it and start it running. Now we could go and create another container image, and this is, let's say, for service B, and it happens to be version 3 of this service B. So it has the service B code in it, it's version 3 of that code. It might have a dependency on the same library L, but you'll notice this needs version 3 of that library L, where service A needed version 2 of the library L. It's okay because these containers are isolated from one another, and so we can have different versions of the libraries in each container image. It could be that service B also requires some other library. I just called it M because M comes after L. And it's version 2 of that library. And then maybe it uses the same runtime engine, but it uses version 7 of that engine, whereas opposed to service A, which uses version 5 of that engine. Right? But again, because they're all isolated, this is perfectly fine and it works great. Then we might want to create service A version 2. As another image. So this has service A version 2 code in it, and maybe with version 2 code we upgraded ourselves to version 3 of the library, whereas version 1 of the service used version 2 of the library. And maybe we've also upgraded our runtime to be version 6 as opposed to version 5 before. So we've created these 3 different container images. They're all self-contained with their own set of execution code, libraries, and runtimes inside them. And now that we have created these 3 different images, we could actually create 3 different containers, each running each of these images, and we can run them all on a single personal computer or virtual machine, all side by side. So a lot of times today, if you use certain runtime libraries, like Java or .NET, you install that runtime on the PC or the virtual machine, and it's that version of the runtime across any other processes that you might have running on that PC or VM. But with containers, it allows us to have the separate versions running in each of those. And that's really one of the big benefits of containers, right? It's these immutable images that are self-contained and that you can deploy them side by side within a single machine, and you keep that isolation boundary going.